All right, so now we're going to go on to design and measurement. Remember, this is the exam from June 2013. Let's get started here. So I have a calculator, highlighter, all of that ready. For design and measurement, I'll say this. Uh, you will need to be familiar with common shapes, right? So you gotta be obviously comfortable with your prisms, rectangular prism. So know your surface area and volume, as well as spheres, right? Know your surface area and volume for that. Triangular prisms, sometimes square-based pyramid. So all of those are game total in the game here for this unit. Okay, so but it's usually around some kind of context. Keep that in mind. We're also going to be gonna have to be able to work backwards. So if the surface area is given for this shape, for example, you should be able to figure out the missing dimensions for surface area and volume of a sphere. You should be able to figure out the radius if you're given one of them. Don't forget about our cylinder, right? That's still there. And there's the hemisphere, which is just half of a sphere. Circles, rectangles, like all those shapes, all those areas, those formulas, make sure you have them on your study sheet, okay? All right, let's continue here. Design measurement, 2 marks for this question. A cake mix will produce 230 cubic inches, okay, cubic inches of batter. You're using a cylinder-shaped baking cups that have a diameter of 3 inches and a depth of 2 inches for the batter. How many cupcakes will you be able to make? So the idea here is you've got a bunch of batter and you want to see, right, if you divide it by the volume in the cups, you'll have the number of cupcakes you will be able to make. That's the idea here. So we already know the total batter, 230 cubic inches. The volume of just one cup, it's cylinder shape, right? So we're thinking this. It's in the form of a cylinder. And so we have the depth of it, which is 2 inches. And we have the diameter, which is 3 inches. So a cylinder, if you want to know how much volume, because we're talking cubic inches, would be pi r squared. So remember, it's the area of the base times its height. That's by definition the volume of any shape, except for when it's pointed like this, then this one would be divided by 3, correct? But in general, that's the idea here. Pi r squared times height. So we have pi. Radius is obviously 1.5 squared, and the height is 2. And everything is in inches. We've checked. Always read very carefully. Okay, what are my units in? And you get, let's crunch this real quick here. Pi times 1.5 squared. All of that times 2. So that's 14.1371. Don't round just yet. Cubic inches for 1 cup. Okay, so we're just going to take 230 cubic inches divided by 14.1371 and something cubic inches, and that'll give us our answer. So 230 divided by our previous answer. There you have it, 16.26 something cups, and it's implied here that you can't have partial units. So you either say 16 cups or 17, okay, that you'll be able to make. So that is the 1 mark. So this would be 1 mark for figuring out the volume of a cup, and then how many cupcakes you'll be able to make cupcakes, I should say, is the 2nd mark here. Okay, continue. A goat is tied to the corner of a barn with a 50-foot rope. The barn measures 60 feet by 40 feet. which is right here in the diagram. Calculate the total area outside the barn. So the area outside the barn that is available to the goat. Show your work. So this goat is tied to that corner, and I guess the maximum area, right? So this goat could swing this way, like keep that string completely like maximum tension on it. And so it could swing this way, and it would, because this is 50 feet, it would probably cut it somewhere in here. Okay, so you can almost imagine this is happening here. And if the goat were to go all the way up here, you can tell that this is 50 feet and that's 40. So it's actually probably going to go up here somewhere. You got to add an extra 10 feet here, and you will have something that looks right. It looks like a circle, doesn't it? With a radius of 50. Except for this area right here. I don't know if you see it, right? This whole chunk, quarter, is gone of that big circle. So I guess we're looking at 3/4 of a circle for this one, large circle, I would say. All right, but then at this point, like this leash here, right, it's 40 feet here. We know that this must be 10 for that reason. And so the goat can technically continue and walk a little bit longer, right? This corner, it's gonna, I guess, attach this corner and still allow the goat to roam around this way. But we don't want to add this because we already figured that out. So this is quarter of a circle right there, just that little quarter there. So that's what we're gonna use to figure out the total area available. So total would be a quarter of the small circle, which is pi 10 squared. Pi times 10 squared plus 3/4. I would always suggest you do that, like focus on the circle and then just figure out, oh, it's 3/4, it's half, whatever the case may be. 3/4, and in this case it would be pi, and the radius of this one is 50 times 50 squared, like that. And then it's just a matter of plugging this in. So I'll go with pi, let's clear first, pi times 10 squared times a quarter, so you can go times 1 divided by 4 or times 0.25, whatever you want, 7539 and something, plus 3/4 of the larger circle, so pi times 50 squared times 3/4. I'm going to go times 0.75 there. That's 589048 something. And I can add these up because they're still on my calculator. So I'm going to go copy paste plus something went wrong there. This is good, but something went wrong here. Yeah, I was supposed to take that one there. Sorry. I copied the wrong 78539 plus 5890. And there it is. 5969.03. And we are in feet. So total area is 5969.03 feet. All right. Moving on. And here are some of the options questions. Okay. This is a total of 4 marks. Keep that in mind for question 20. So Manitoba Beach Volleyball Association has asked you to design a souvenir beach ball according to the following information. The beach ball must have a volume between 1 and 3 cubic feet. The plastic material costs 15 cents per square foot. Labor and other materials are $1.25 per beach ball. And the association wants to make a profit of 80% of the cost of making each beach ball. Based on your design, what is the minimum selling price for each souvenir beach ball? Show your work. Okay, so this is where the choice comes in. Don't fear this, just go with it, right? So you can have a beach ball that is between 1 and 3 cubic feet. And because it says between 1 and 3, I'm assuming are not acceptable. So I'm going to pick 2. You could pick 1.1 or 2.9, anything in between, 2.5. I'm going to choose 2, okay? Based on your design, right? I choose 2 cubic feet for the ball, for volume of ball. All right, so what does that mean? That's how much air, I guess, can fit in it. The plastic materials to make it is 15 cents per square feet. What does that mean? I need the surface area of this ball. How do I find the surface area? I need my radius. So in a sense, you're supposed to go backwards here, right? You know that the volume of a ball, of a sphere, would be 4 pi r cubed over 3. Yes, I know what you're thinking. Great, right? So the 2 goes in there. So I'm going to be careful with my spacing here. So 2 is equal to 4 pi r cubed over 3. So now we'll isolate r. I'm going to multiply both sides by 3. Okay, so cancel, cancel. So I'm left with 6, 4 pi r cubed. Then I'm going to divide both sides by 4 pi. Cancel, cancel. I'm going to leave. I guess I can do this with a calculator. You have to be very careful here. 6 divided by, don't go, this is wrong, divided by 4. Sorry. 6 divided by 4 times pi. That'll give you the wrong answer because it will only divide by 4 and then multiply that answer by pi. So I'm going to go like this. 4 pi in brackets. Then you're talking. So it's 0.477 and something. That's r cubed. So how do you get r? You have to take the cube root of both sides. So that's how you find r. And it's a bit of a pain in this calculator, so you got to go math and then fourth option of your previous answer. Copy paste that. That's 0.7816. And that is in feet. So this is important. You would definitely be getting a mark for that. And so that will allow me to determine the surface area. Surface area, to figure out how much plastic I need, it's 4 pi r squared. So that would be 4 pi 0.7816. Notice that I rounded to 4 decimals because I'm not done yet. So I'm going to go 4 pi times 0.7816. If you want to use all decimals, go for it. 9.8219. Let me just check here. 4 pi. Oh, I didn't square it. I was just looking at my screen here. There we go. That's more like it. It's 7.6768. Okay. And that would be square feet. So that's, now I know how much plastic one ball needs. So plastic needed, right? I would just go 7.6768 times, right, the 15 cents. And so that would be $1.15 per ball that I will have to pay to make it. And so total cost, it's 115 per ball for the plastic, plus it's another 125 for labor and material. And that ends up being 240. You would definitely at this point be at the 2 to 3 mark already that you would have earned at this point. One here, one there, yeah, probably 3 marks so far. And now we want to figure out, that's the total cost, you want to make a profit. Okay, so you figure out to make a profit of 80%, well, obviously you're going to add 80% to that. So you go 240 times 0.8. So 240 times 0.8, that's $1.92 on top of that. That's a markup, right, that you're going to put on top. So sell price would be 240. That's all the cost plus the profit you want to make. And so that would end up being $4.32 per ball. Yes, 4 marks. Haven't seen a long one like this in a while, but be prepared for it. Think it through. So this is the minimum you charge to make that happen, right? Keep going. Logical reasoning. This is always where you kind of want to know the conditional statements. Okay, so I will review that before we start this question here. I'll just tell you that. And to review, the first part of a statement is P. The second part of a statement is Q. We usually have P and Q. Okay. That's just a statement. Let's say that P represents your breathing. And Q represents being alive. Okay. So this statement would say, I am breathing. And alive, or something like that. Let's say that's just a statement you're thrown. Sometimes we start right with a conditional, sometimes it's just a statement. If you want to turn this into a if P then Q, right? Breathing is the P, being alive is the Q. You would say if I am breathing. Then I am alive. Okay, that's the if then. Then you have, this one is called conditional. Then you have what we call the converse, Q, if Q then P. So you basically just flip this, right? If I am alive, then I am breathing. They use various scenarios with these types. So sometimes it's, if there's 2 congruent sides for a triangle, then it's an isosceles triangle. Anything goes here, but the logic is still the same. This is what we call the converse. Then we have the inverse. That would be taking the if P then Q, but negating both of them. It's called the inverse. I would definitely have these on my study sheet. So you basically just go with the original if then. You just say if I am not breathing, then I am not alive. And the last one would be the flipping and negating. So you flip, you go P and Q flipped, and they both have a negation on top. So this would be, so then remember Q is alive, okay? If I am not alive, then I am not breathing. That's the contrapositive. And the last one, actually, we didn't talk about this. It's this one, or in a while at least, when the arrow goes both ways. This one is the biconditional. So this would read, I am breathing. Sorry, what happened there? I am breathing if and only if I am alive. That's the if and only if part that is in between. Now I want to tell you this. Logically, these two are the same. The conditional goes with the contrapositive. They're logically equivalent. You are saying the same thing either way. And so is the converse and the inverse. They are logically equivalent. Okay. I'm just going to say that they're equivalent to each other. So that's something that's probably also worth mentioning. And one more thing with regards to whether or not a statement can be proven to be true or false. The biconditional is only true if no counter example. Okay? If there's no counter example to be had, then that you go with it if and only if is true. Okay, so I'm going to highlight that. And last but not least, I might have to do this more in class, but I don't know if you remember the truth tables, but if you consider P and Q like this and all possible ways to answer it, so you go true, true, false, false, true, false, true, false. And doing it this way, you come up with every single scenario. If you're wanting to know, oh sorry, P, Q, right, separately as statements. If you want to know if P then Q, which one of these statements would be true? If both are true, then definitely this is true. If the first part is true and the second part is false, that is always a false statement. In fact, all the other ones are going to be true. So that's something to remember. If the first part is true and the arrow points to the false, right? That is a false statement. In all the other scenarios, you're not lying in doing so. Okay. How about this one? I don't know if I'm going to fit that on here. I'm just going to leave it like that for now. Hopefully that's enough. So knowing all of this, rehashing all of this, let's answer this multiple choice question. 1 mark. Given the statement, if the temperature outside is below -40, then schools will be closed. Circle the contrapositive. Okay, so you're looking for, basically you're looking for the one that flips the P and the Q and has a not in front of it. So let's see here, this might be it. If schools are not closed, then the temperature outside is not below -40. That is the contrapositive. This is contra. What about this one? If schools are closed, then the temperature outside is below -40. This one is just doing if Q then P. This is the converse. This one is saying this. And C, if temperature outside is not below -40, then schools will not be closed. This is the inverse. This is saying if not P, then not Q. D, schools will be closed if and only if the temperature outside is below -40. This is the biconditional. In notation, right, it's saying this. Okay, so review again of what we've just talked about. But again, not if you have a study sheet that has these uh, down, an example, and also using the correct notation, you should be fine. Next, our beloved Venn diagram. A sample of 100 families was surveyed, and the electronics, right? What devices they had at home. So we know that this is 100 here, or universal. The Venn diagram shows the number of families that have a computer, a DVD player, and a Blu-ray player. How many families have all three electronic devices in their homes? I would hope that you would know that 5 families is the answer. 5 families. And then how many families do not have any of these electronic devices in their home? Like they're asking for the outlier. They haven't given that to you. So I'm going to say, I'm just going to go 100 minus, it's going to be very busy here. I already did the math for this. So this circle here is 87. So I'm going to go 100 minus 87, right? That's gone. Minus 5, minus 4, minus 2, right? You still take these away. So you want all of these away to get your outliers. And that would be 2. Okay, you get 2 here. And that's what that question is really asking for. How many do not have any of the electronic devices? They're asking for this. Computer and DVD player and Blu-ray player not. So that would be 2 families. In other words, they didn't ask for it, but I just review everything just in case. Okay. I'm going to make an arrow down here as well. Keep going. Almost done. Question 23. One more after this. Mark wrote the statement, an isosceles triangle is equilateral. Rewrite the statement in if-then form. So I'll just say, I'm assuming an isosceles triangle is P is equilateral as the Q part. So if an isosceles triangle, if, how would we say this actually? This doesn't actually sound right. If a triangle is isosceles, then it is equilateral. That's how I will write it. I don't know if you just sometimes have to try things and see. So I will rewrite this. If the triangle is isosceles, then it is equilateral. We're not saying whether or not the statement is true, but that's how you would rewrite it. Okay? If then. Because you have to have, if something happens, then something else is true. And equilateral is definitely our Q. This part is our P, so I just had to think about how would I set it up to make it an if-then statement. Next, provide a counterexample to show that the if-then statement is false. When is the statement false? If the first part is true and the second part is false, then the whole statement is considered false. That would be the a counterexample in a sense. So you can give an example here. Example, you can make it very simple. You say this is 7 meters, 7 meters, 8 meters. And you can clearly tell this is not an equilateral, but it is an isosceles. Okay? So I don't know if you want to go technical, triangle ABC is an isosceles triangle, but it is not an equilateral triangle. That's a counterexample. So then that statement is false because this one is isosceles, but it's not equilateral, so the statement is false. That's what a counterexample does. Last but not least, the following students attend the same school and participate in extracurricular activities as listed below: basketball, right, and then tutoring group and volleyball. Okay, identify two sets from the above that are disjoint. Disjoint is the same thing as mutually exclusive. So you got to find two sets that have nothing in common. So let's see, B and T. Oh, Jackie is there both. No, this one doesn't work. So let's try B and V. Jackie, no Jackie. Lisa, no Lisa. Mangu, no Mangu. Maya, no. Nora, no. Sabrina, no. So B and V, okay? Sets B and V are disjoint. They don't ask us to explain, they just want us to know which ones are disjoint, to state, I guess. Then it asks, determine B and T, right? That's intersection. That's this symbol right here, intersection. So it doesn't say the number of elements, it just wants B and T. So we're going to say, okay, we look at B and T here, and which ones do they have in common? Jackie, Mangu, and Sabrina. That's it. Remember that technically elements in a set should be should be arranged alphabetically, numerically, whatever the case is. So we've got Jackie, Mangu, Sabrina. That's it. And notice that n of B and T, then we would just want the number of elements, so then we go 3. Okay. That's it. Union. What would the union be of the two? Well, that's when you list both of them combined, but you do not have don't have don't duplicate any entries. Sorry, I was stumbling there. But this is the end of the test. I'm just gonna bring my key here and just add a few things. I have BNT's list of shared elements. N BNT is 3 number of elements in the set. And I review 2 sets here, universal, these are your outliers, that's how we write it. This would be only A here, that would be this section right here. Only B is here, and you write it like this, right? B not A. In this case, you would go A not B. This is both, which is A and B. The union would be everything here, everything that's inside those sets that you're trying to combine. With 3 sets, you got to watch out. If middle is given, you put the middle in, you work your way out. If it says B and C only, I'm talking about just this section here. Okay, that's where the number would go. If they ever gave you something, you would just put it in there. You would not assume that it's that whole intersection. If it's A and B, like this part, yes, then it's actually asking us for the whole thing. Okay. Then it's giving us that whole slice there. And so keep that in mind. That's it. Thank you for your time. Have a good one.